Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. Today we are going to discuss about the next topic from the chapter acid, bases and salt. The title of the topic is how strong the acid or base solutions are. Okay, yes, let me write down the title and then we will start for the discussion. It belongs to the chapter acid, bases and salt. Acids, bases and salt. This is the title of the chapter from which this topic belongs to. Then title of the topic today for today's discussion is how strong are acid or base solutions. Acid or base solutions. How strong are acid or base solutions, right? That means in today's class we are going to discuss about the strength of the acids, right? Strength of the acids or strength of the bases. Do you remember, students, in the last class we have seen about the what happens to acids or bases or acids we have discussed, or what is the common factor present in acids and bases. That part we have discussed in the last class, and that is nothing but all of them have H in them. The proton can be donated from them, right? H plus in them. H plus is also called as a proton, but that proton does not remain as a proton in the acid for long time. That protons immediately combines with the water. As you know, acids or bases, we are using the aqueous solution of them, right? So aqueous solution stands for solution in water. So what happens to them when we add them to the water solution, that part first of all we are going to discuss. Okay, so I'll write down one simple reaction here. So if I'm taking HCl, okay, now if I'm let me just write down it like this. So this is HCl, and if I'm treating it with the water, so water is nothing but H2O. I'll write down the structure of water like this: H2O. Okay, water molecule contains oxygen atom which has two lone pairs of electrons, right? That is the tendency of oxygen or group 16 elements. Okay, now what happens here, we know very well, the this bond is a polar bond. This is delta, let me just use another color. Okay, this bond is a polar bond. This is delta minus, this is delta plus, right? What happens, therefore this bond gets shifted on chlorine, right? And therefore what happens, hydrogen, this hydrogen, it becomes electron diffusion because it has lost its bond, right? Therefore it needs electron. So where are the electrons in the solution? Electrons are present on the oxygen, so those electrons will be given to the hydrogen. That means this oxygen and this hydrogen, they are going to connect with each other, right? Okay, so what will happen after this, let us see. First of all I will write down Cl minus. Cl minus will be removed here. Why Cl minus? Because chlorine is taking these two electrons with it, right there, and this is called as chloride ion, right? This is called as chloride ion. Okay, what happens to water? Yes, so first of all it is like this. Out of two lone pairs of electron, one has been used for bonding with the proton from acid. Okay, so only one lone pair of electron I will write down on oxygen, and one hydrogen is attached to it. So here on this particular oxygen, there are three bonds attached to it and one lone pair only. Ideally there should be two lone pairs, so I will write down a positive charge on this oxygen, right? So there will be a positive charge on this oxygen atom, right? Now this ion which is produced here after combination of H plus and H2O, it is called as hydronium ion. Okay, what is the name of this ion? It is called as hydronium ion. Okay, so what is the tendency of acids? Tendency of acids is to donate the proton. That proton which is donated by the acid, this is the proton, right? This proton combines with water molecule. Okay, water molecule has two oxygens on it. This proton combines with that water molecule and we are getting H3O plus. H3O plus stands for hydronium ion, right? H3O plus stands for hydronium ion. Okay, so instead of writing H plus, you can write down H3O plus in the reaction when we are writing it for the acids, right? H3O plus stands for hydronium ion. Okay, yes, first of all you can take a screenshot of this page. If you have any questions in between, please let me know in the chat box. I'll just write down one message in the chat box. I hope you have written it. Now let us see what happens to the bases when we are adding them to water. What happens with bases when we add them to water, right? Yes, so here a simple example of base I will take. So in case of bases, only dissociation will take place. Okay, if I am preparing its solution with water, aqueous solution, only dissociation take place into Na plus aqueous and OH minus aqueous. That's it. Okay, in case of this, OH minus is not going to combine with water further, right? Similarly, I can write down some other reaction. So KOH, potassium hydroxide, it also when dissolved in water, it gets converted to K plus aqueous and OH minus aqueous, right? Like acids, we are not going to combine anything with water here. And one more example I will write down for bases. Magnesium hydroxide, MgOH twice, solid. If I am dissolving it in water, okay, I get two ions. I get three ions. One is Mg2 plus aqueous and another is 2OH minus aqueous, right? So this is how we can write down these reactions, which are nothing but the dissociation or ionization reactions. Okay, these reactions are called as dissociation. Means what? Because molecule is getting broken down, dissociated, or these are also called as ionization, as the product of these reactions are ions, cation and anion. Therefore this is also called as ionization reaction. Okay, yes, now these were the reactions for bases. So in conclusion, I will write down one simple statement here. These two statements are very important. Acids give hydronium ion. Hydronium ion, that is H3O plus, or we can say instead of hydronium ion, proton also, right? Or proton. Proton is nothing but the H plus in water. Okay, but here when you write down proton, you need to write down the aqueous inside the bracket. Aqueous, you can either write down H3O plus or you can write down H plus aqueous. Only H plus will not work. In water. Okay, this statement is for acids, and for bases the statement I will write down. Bases give hydroxide ion. Hydroxide ion. Hydroxide ion is nothing but OH minus in water. Okay, then one more statement for bases only. Bases which are soluble in water are called as bases which are soluble in water are called as alkali. Okay, therefore, one more statement here I'll write down. Therefore, hence so but before that, so group number 1 elements of the periodic table elements form form water soluble bases. Okay, for example, NaOH, KOH, etc. Right? Therefore, group number 1 elements are also known as alkali metals. Okay, this we have learned already in the periodic classification of elements. Okay, this is the reason we call group number 1 elements as alkali metals. Okay, so these are the important things related to the acids and bases dissociation reaction. You can take a screenshot of this page first of all. Remember one more thing here I'll write down, and then you can take a screenshot. Just give me a second. Dissolution, that is dissolving. Okay, dissolution of acid or base in water, that is preparing the aqueous solution, is highly exothermic process. Exo means out, therma stands for heat. Exothermic process. This reaction is highly exothermic process. Therefore, we should take extra care while preparing its aqueous solution. Right? Like here, if we take acid in beaker and if we add water to it, as reaction is highly exothermic, there will be explosion. Right? Therefore always remember add acid. Okay, what you have to remember, therefore AA, that is add acid. Remember, okay, add acid technique you have to remember. That is you can take add acid means what? Take water in container or water in beaker, and then add acid drop by drop or very slowly. Okay, yes, so this is also very important. Now just take a screenshot of this page. This is because the reaction is highly exothermic in nature. Okay, yes, now I hope you have taken a screenshot. Now we are going to discuss the next concept from this chapter, and that is about the pH. Okay, let us see what is pH. Now pH is nothing but the way to express the concentration of acid or base. Right? pH gives you the idea about the concentration of acid or concentration of a base. So here the P stands for, okay, P is nothing but potens, okay, potens, which is a Greek word whose meaning is potential or capacity, potential or capacity. H stands for the proton, okay, H stands for proton, that is nothing but the H plus ion. Okay, so what is the pH? pH is nothing but how easily that acid is going to donate the proton. Okay, I will repeat, the pH is nothing but how easily that substance is going to donate a proton, that is its pH, P small h capital, okay, that is its pH, P small h capital. P stands for potens, that is potential or capacity or ability. H stands for proton, H plus ion, right? Okay, now before explaining the pH, I will just explain some other things to you. Okay, so and consider that HCl is the acid, right? We know that. So when we dissolve it in water, what we get after dissolving it in water, we get the H3O plus, H3O plus, or instead of H3O plus we can write down H plus aqueous also, right? H3O plus or H plus aqueous and Cl minus ion, right? Cl minus aqueous ion. Okay, now if I want to write down the dissociation constant for this reaction, okay, what is the dissociation constant? How easily H and Cl are going to separate from each other, how they are going to break from each other, that is the dissociation constant. Dissociation constant gives you the idea about how easily dissociation takes place. So dissociation constant of acid, I will write down, it is denoted by the symbol Ka, is equal to the concentration on the product side, okay, product side divided by concentration on the reactant side, divided by concentration on the reactant side. Okay, that means this will give you the idea about how easily the acid is going to donate a proton. Okay, this will give you the idea about how easily that particular acid is going to donate a proton. That means how strong that acid is, simply. Okay, how strong that acid is, simply. Okay, now one more, according to this Ka, the pH will be calculated, or according to the H plus ion concentration, pH will be calculated. There is one formula used for calculation of the pH. What is that? pH is equal to negative logarithm of H plus ion concentration. pH is equal to negative logarithm of H plus ion concentration. This is really very important formula. It will be helpful for you to solve the questions. Very, very, very important formula, guys. pH is equal to negative log of H plus ion concentration. Very important formula. pH is equal to negative log of H plus ion concentration. Okay, now how to do this calculation part, that also I am going to explain to you. But before that, let me just tell you about the pH scale. We are going to see the question based on this formula, but before that, let us see the pH scale. Okay, what is pH scale? The scale which denotes the acids and bases and salts concentration, right? Okay, so that scale starts from 0 to 14. Okay, that scale starts from 0 to 14. Let me just show you the simple diagram for remembering pH. So yes, so this, if I write down, this is about the pH. Okay, yes, so this is about the pH. So if it is 0, then 7, then 14, right? Meanwhile there will be 0, 1, 2, 3, 4, 5 and 6. There will be 8, 9, 10, 11, 12, 13 and 14, right? Okay, this is nothing but the pH scale. Okay, yes, starting from 0 to 14. Okay, now let us see how it is divided. Exactly at 7 pH, exactly at 7 pH, the solution is a neutral solution. Okay, pH exactly equal to 7 is the neutral solution. Okay, yes, now pH exactly equal to 7 is the neutral solution. Less than that, pH less than that, up to this, okay, pH less than that is the acidic solution or acidic or acids you can say. Okay, now for acids the pH is less than 7. Okay, it is not equal to 7, it is less than 7, whatever may be the number, it is less than 7, less than 7, always remember. And this one starting from like 7 onwards up to 14, not 7 exactly, 7 is neutral. So this is about the base. So bases have pH greater than 7. Okay, bases have pH greater than 7. So this is called as a pH scale. Okay, this is called as a pH scale. On the basis of this, if I want to write down the few things, that is pH is inversely proportional to acidic strength. Okay, acidic strength means how strong that acid is. pH is inversely proportional to acidic strength and pH is directly proportional to basic strength. Okay, pH is inversely proportional to acidic strength, pH is directly proportional to basic strength. Right, as pH is increasing, basic strength will increase, as pH is decreasing, acidic strength will decrease. Or, and one more thing I am going to write down here, and that is about pH is inversely proportional to the H plus ion concentration. Right, pH is inversely proportional to H plus ion concentration and pH is directly proportional to the OH minus ion concentration. Okay, directly proportional to OH minus ion concentration. H plus means coming from acid, OH minus coming from base. So these are some formulas related to the pH. So you can just take a screenshot of this page first of all, and then we will discuss some question based on the pH. These formulas are very, very important. Okay, I hope you have taken a screenshot. Now let us see some question based on the pH scale. Okay. Yes, so first and simplest question I will write down, and calculate the pH of an aqueous solution of hydrochloric acid whose concentration is 0.1 molar. Okay, where molar stands for molarity, molarity word I have shown to you. Molarity is nothing but one of the way quantitative method to express concentration. There is express the concentration of solution. Okay, now you need not to worry about it, you simply have to worry about this digit, this the what is the concentration, this part we have to worry about. Okay, yes, so let us see what is given. Concentration, whenever something is written in the square bracket, that means it is its concentration. Concentration stands for amount of the substance in that solution, amount of HCl in that solution. Now HCl has only one H, therefore concentration of HCl is nothing but concentration of H. If it was H2SO4, then that in one H2SO4 there are two H, so that will be a different case. Okay, we are going to see that part also, but later. HCl has only one H, therefore concentration of HCl is equal to concentration of H plus, right? Okay, yes, now that is equal to 0.1 molar. Okay, 0.1. We know the formula for pH. What is the formula? pH is equal to negative log of H plus ion concentration, right? H plus ion concentration is given, so it is equal to negative log of 0.1. Okay, now when you are solving such a type of question, the log values of complicated numbers is provided in the question itself, but some tricks to find out the log also I am going to tell you here. Okay, yes, so let us see first of all some tricks. The tricks I will write down below, and then these questions I'll solve. Okay, tricks for the log, tricks for logarithm. Okay, so let me just write down them. So always remember, the log to the base 10 of 10 power x is always equal to x. Okay, log to the base 10 of 10 power x is always equal to x. Just give me a second. Okay, log to the base 10 of log to the base 10 is the normal thing only. Okay, yes, 10 power x is equal to x. The next formula I will write down, log of sometimes they write only log means log to the base 10 only. Okay, I'll write the same to avoid the confusion. Log of x into y is equal to log of x plus log of y. Okay, the next trick I am going to write down here, log of x divided by y is equal to log of x minus log of y. So these are some tricks to find out the log. Okay, yes, you can take a screenshot of these tricks also, but later. Okay, so let us see. So here you can see it is 0.1. Okay, 0.1 means what? 0.1 is nothing but 1 divided by 10. 1 divided by 10 is nothing but 10 raised to minus 1, 10 power minus 1, right? 1 divided by 10 is nothing but 10 power minus 1. So that part I am going to write down here. So it is equal to negative log of, instead of 0.1 I will write down log of 10 power minus 1, right? So it will be equal to the log of 10 power minus 1. Okay, as we know, log of 10 power x is equal to x, therefore log of 10 power minus 1 will be equal to minus 1, right? This thing I will write down. So minus inside the bracket, log of 10 power minus 1 is minus 1. Minus 1 will be equal to plus 1. So what is the pH of this solution? pH of this solution is equal to 1, right? pH of this solution is equal to 1, right? So this is how we can solve the questions based on the pH of the solution. Okay, you can just take a screenshot of this whole page first of all, including the question. Take a screenshot, guys, and just go through the question one more time. Okay, I hope you have taken a screenshot. Now let us see one more question of the same type. Next question: calculate the pH of 0.2 molar H2SO4 solution. H2SO4 is the sulfuric acid, right? Yes, for HCl, if you remember, we have seen for HCl only one H was present. Therefore, H plus as well as HCl concentration were equal to each other because HCl contains only one H in it. But if you see H2SO4, it has 2H in it, right? H2SO4 has 2H in it, right? Therefore, the concentration of H2SO4, right, whatever is the concentration of H2SO4, just a minute, guys, I will take pH of 0.5 molar H2SO4 we will see. So concentration of H2SO4 is equal to 2 multiplied by concentration of H plus, right? Because one H2SO4 will give you 2 H plus ions, right? Therefore, concentration of H plus will be equal to like this. Concentration of H plus will be equal to 2 multiplied by concentration of H2SO4, because one H2SO4 will give you 2 H plus ion, and it is equal to 2 multiplied by 0.5, and that is equal to 1 molar. Okay, so 1 molar is the concentration of this one, right? Okay, now let us find out the pH. pH is equal to negative log of H plus ion concentration. So it is equal to negative log of 1, right? Always remember, log of 1 is equal to 0. Okay, therefore what is the pH? pH of this solution is equal to 0. Okay, so this is how we can solve the question based on pH formula. Okay, take a screenshot of this page also. I hope it is done. So that's all for today, guys, and in the next class we are going to discuss about the next part from this chapter, and finally, before ending the class, I'll just let you know about the daily practice problem. So here for daily practice problem, you can see This is a teacher's portal actually. So similar will be the portal for students. You have to go to resources, then to writing material. In that you will see DPPs. You can see the DPP. You can upload the DPP. Solve the question, all the questions on the notebook or on a blank paper. Take a picture of that blank paper and just upload it in the portal. When you upload it in the portal, I will be able to see those solutions by students, and I will evaluate them and let you know the suggestions and corrections in it. Okay, so that's all for today. Thank you so much, students, for your precious time. Just remember to solve the DPPs on time. And yes, so that's all for today. Thank you so much and bye. Take care.